In this video, we're going to introduce the idea of the inverse of a matrix. So just to remember, there are inverses of numbers that we talk about all the time. For example, the additive inverse of a real number is just its negative. For example, the additive inverse of 3 is -3. And the reason that's the additive inverse is because if we take 3 and add to it its additive inverse, that gives us 0, which is the additive identity. And 0 is the additive identity because if we add 0 to any number, we just get that number back unchanged. Numbers also have a multiplicative inverse, well, all the non-zero numbers, and the multiplicative inverse of a number is its reciprocal. So, for example, the multiplicative inverse of 3 is 1/3. And that's because if we multiply 3 by 1/3, we get the multiplicative identity, which is 1. And 1 is called the multiplicative identity because if we multiply anything by 1, we just get the same number back, assuming that we're multiplying a non-zero thing by 1. So matrices also have additive and multiplicative inverses. So let's see some examples of those. So here's a matrix A, a 2x2 matrix, and I want to show you what the additive inverse and the multiplicative inverse of this matrix is, just so we can compare this to what we already know about the additive and multiplicative inverses of numbers. The additive inverse of a matrix, just like the additive inverse of a number, is just its negative. And the negative of a matrix is just the scalar -1 times the matrix, which means it's just the matrix that has as entries -1 times all the entries in the original matrix. And this is the additive inverse because if we add it to the matrix A itself, we get back the additive identity. The additive identity being the 0 matrix. And the 0 matrix is the additive identity because if we add it to something, provided that we have the right dimensions, we'll just get the same thing back again. So if we added M plus the appropriate 0 matrix, we would just get M again. Now, the multiplicative inverse of a matrix is a little trickier to compute, but let's just see some examples first before we start trying to compute these. So the multiplicative inverse of this matrix A above is the following, and I don't want to try to explain where that comes from yet, but we'll talk about it in the next video. I just want to introduce the notation here so you know how sometimes we write the multiplicative inverse of a number using a negative exponent. Like we know that 2 to the -1 is 1/2, and that's because 1/2 is the multiplicative inverse of 2, right? So if we multiplied 2 by 1/2, we'd get 1. The same notation is used in the world of matrices. So the inverse of the matrix A, we write as A to the -1. And the reason that this is the multiplicative inverse is because if we multiply A by A inverse, we'll get what passes for 1 in the world of matrices, that is the identity matrix. So let's check to see if that's really true. So let's multiply A by A inverse. So if we use the multiplication algorithm for two matrices and multiply this out, you can check. You'll have -1 times -7, that's +7, -3 times 2, so this will be plus -6. For the next entry here, we'll have 3 plus -3. And for the 2, 1 entry, we'll have -14 plus 14. And for the 2, 2 entry, we'll have -6 plus 7. So that gives us the identity matrix 1, 0, 0, 1. And in fact, you can check that if you multiply in the other direction as well, you can work this out yourself, you'll also get the identity matrix. And that identity matrix is the multiplicative identity. So when we write A inverse of a matrix, we're talking about an inverse that works on multiplication on both sides. So that's something to remember about matrix multiplication, right, is that it's not commutative. So when we talk about matrix inversion and finding the inverse of a matrix, we're always talking about square matrices. Non-square matrices can have things like left inverses and right inverses, but they don't have this kind of thing, like what we would call a two-sided inverse that works multiplying from either side, the left or the right, to give us the multiplicative identity. All right, so we're going to have lots of opportunities to compute the inverses of matrices, and that's what's coming in the next videos.